Hi, everyone. My name is Protásio, and I am the Administrative Director of the Brazilian Society of Microelectronics, in short, SBMicro. And I would like to welcome all of you to this talk that we call SBMicroHUB. Okay? But why we call this a hub? It is because we would like to connect the greatest company in microelectronics of the world with students, teachers, researchers, professionals, and everyone in Brazil who is interested in microelectronics. Okay, so the idea is to give to all of us a place, an online place where microelectronic company can share what they do with our audience. It gives opportunity to us to ask questions directly to the top level executive and leaders of the companies here in Brazil and in the world. Okay, that is the idea, and also the SB Micro Hub. It is like we would like to transform the hub in a like a job fair. Okay, I will ask the leaders, the executives of the companies, what opportunities do we have to work in the company. Okay, so we will have the opportunity to know what knowledge and skill, soft skill, technical skill they are currently looking for their future employees. So also, if they have some open position and opportunities here in Brazil or who knows in the world, okay? And there is some important thing. What a beginning student in microelectronic technician, master or doctorate student can do right now to get a future position in a microelectronic company. So today we'll have one of the top EDA company in microelectronics of the world that is headquarters in Silicon Valley in the city of Santa Clara in California, USA. The name is Silvaco. Thank you very much, Dr. Raul Camposano and Mr. Bernardo Culau to be here with us. And it is important to know that Silvaco is headquartered in USA, but also has offices in Europe, Asia, and there is an office here in Brazil, in Porto Alegre, Rio Grande do Sul, that hold a research and development center in Porto Alegre, okay? So it is like important to highlight that Silvaco is one of our sponsors, okay? Então, thank you very much, Silvaco, to be a sponsor of the SB Micro. So let's go. We have two speakers today, okay? The first one will be Dr. Raul Camposano, who is the CTO of Silvaco, and he is going to talk about the company, its main product, the challenge and opportunity in the market for semiconductor in a global perspective, okay? And of course, his vision on Brazil, okay? Our second speaker will be Mr. Bernardo Culau, who is director of the library characterization at Silvaco and leader of Silvaco Research and Development Center in Brazil. He is going to talk about Silvaco present here in Brazil and some opportunities. Okay. So the last session will be the question and answer session at the end of the presentation. And I ask you all to leave your comment here, below here, and it could be in English or in Portuguese, okay? Feel free to leave any comment to our speakers, okay? So, firstly, we would like to thank you very much, Dr. Raul Camposano, the Silvaco CTO, for our invitation to be here with us. And without any furthers, any ado, I will pass the floor to you, Dr. Raul Camposano.
Muito obrigado, Protásio. It's a pleasure to be here, right? Always a pleasure to be in Brazil, even if it's no physically. I've been there many times to many of the events, and I have many good friends in Brazil. So it's really a pleasure to do this. So what I will do today is to give you a brief company overview of Silvaco. Silvaco is one of the larger EDA companies. We're still privately held. We are not a public company, but we have over 600 customers worldwide. In addition to that, we work with 200 universities, some of them in Brazil. We have 250 employees, many of them masters and PhDs in computer science and electrical engineering. In terms of what we do, we are number one in TCAD and modeling for flat panel display solutions and for power electronics. We have general solutions not only for that, but also for systems on a chip, IoT, fab process optimization, etc. And I will tell you a little bit more about those in a minute. And we do targeted academic research and sponsorships, many of them actually with universities, and some of our advanced technology comes from these kind of cooperations. Our leadership team, just very quickly, right? Babak is our CEO, Bob is our CFO. I joined the company not too long ago in February of this year. I'm the Chief Technical Officer, and Ayan Chen is our Senior VP of Revenue. I'm an EDA person. I worked in EDA all my life. I started my career at IBM. I have a PhD from Germany in computer-aided design. I worked a lot of time at Synopsys. I did a few startups. The last one of that was Sage, which we sold to Applied Materials. And I also teach a class on EDA in Stanford once a year for 3 months. So let's go to Silvaco. What are our solutions? We have a very broad technical spectrum of solutions, which goes all the way from simulating the very detailed, what you actually need to build single devices and semiconductor processes, all the way to systems. We have essentially 3 businesses: TCAD, analog custom design, and IP. I'll go into details a little bit in a minute, right? But if you look at this overall, TCAD is used at fabs to simulate processes all the way to devices. The models that come out of that, the PDKs, is what goes into the typical EDA solutions, into the EDA software. Those allow you to design systems. We play in terms of design only in analog and custom design, not in digital. And then as you put the things together, right, you do complete systems. And here the business for EDA companies is typically IP, pre-designed blocks such as processors, ARM, RISC-V, memories, standard cells, etc. In design IP, again, right, we play both in analog and digital. Our technology portfolio, as I said, includes 3 things. We have a TCAD solution, which is number 1 in display in particular. We do both 2D and 3D process and device simulation all the way down to the atomistic level. And we have enhanced our solution lately with a little bit of AI to do design of experiments, right, with machine learning. Design of experiments is something you do in the fabs to decide which kind of wafers you would run to get the maximum amount of data, and then use that data to come up with models, which you then have to calibrate, of course, right, to be able to ramp up fabs a little quicker. In EDA proper, we have analysis and verification tools. These are centered around a SPICE simulator, right, with all the things that you have around them: variation analysis, interconnect analysis, parasitic reduction. We also use here a little bit of advanced modeling, particularly in accelerated Monte Carlo simulations, etc. And then we have in addition to the analysis, we also have design. We have a complete analog custom design ID flow, which goes all the way from schematics to layout, GDS2, and then we also have design rule check, of course, and extraction, so that you can get the complete solution from us. Or we also sell the things, of course, as single tools to enhance third-party flows with our point tools. And then last not least, we sell IP management. Here, the business these days comes in two flavors. One is software tools, such as enterprise IP management products to manage your IP, but we also have a large IP portfolio of IP proper, right, in the areas of automotive, IT, memory, standard cells, etc. We have a strong global presence. We have two main offices in the US, our headquarters in Silicon Valley, and we have an office in Atlanta. In the Americas, we also have an R&D center in Porto Alegre in Brazil. That's what we'll talk a little bit more. Bernardo will give you more details later on. We have a few centers in Europe and then in Southeast Asia, of course, where a large part of our business is. If you look at our customers, we essentially play at all levels. If you look at the top 10 semiconductor companies in terms of revenue, right, most of them, as a matter of fact, 8 out of the top 10 use some of our solutions. Some use TCAD, some use IP, some use IC design. If you look at power device companies, which is a particular segment of that, right, again, you can see that among the top 10 companies, 8 use our solutions. And then we are also number 1 in terms of business with display companies in TCAD, and you see that 8 out of the 10 largest companies that do displays, right, use our solutions. In particular, most of them use our TCAD tools. We develop most of our technology in-house, but we also do acquisitions, right? And in the last 7 years, we've done 10 acquisitions in TCAD, IP, and EDA. Perhaps the ones to emphasize here, right, is Nangate and Dolphin, because some of those activities of these companies were done in Brazil and continue to be done in Brazil. And so Bernardo afterwards will tell you a little bit more of what in particular we do there, right? This has to do with IP, foundation IP, and memory compilers. So in terms of the actual solutions, I will tell you very quickly, since I'm sure most of you are familiar with EDA, what exactly we do in TCAD, EDA, and semiconductor IP. In TCAD, the typical 2 parts that you have is process simulation and device simulation. Our product suite is called Victory. We have Victory Process, Victory Device. We do this in 2D and 3D, as I told you before. So you can simulate processes all the way to, as you layer the different materials, right, to complete devices. The devices can then be simulated very accurately, right, transistors, FinFETs, TFTs, etc. Also the interconnect, all the way down to the atomistic level, right? This is something that we developed in partnership with Purdue University. So that's a good example of technology which we sourced from academia and developed together with academia. And at the end of the day, what you want to do with TCAD is, of course, to ramp up your fabs quicker, to get to yield quicker, but also to come up with the models, with the PDKs and the SPICE models, the compact models, that interface with the EDA tools. And here we come up with the parasitic values, with resistances, capacitances, etc., with our Victory RC Pro extractor, which is based on electromagnetic fields solvers. And we also have a SPICE model generator, Atmos 4, that's actually our oldest product, which takes data either from measurements or from TCAD simulations and converts them into simple, compact, so-called models for SPICE. In terms of EDA, we have an analog custom IC design solution, which goes all the way from schematic capture through a layout editor, and then the analysis tools, right? Smart DRC and LVS, which is the physical verification part, we have this qualified by several fabs, and then the parasitic extraction in form of Hypex. We also do simulation analysis. Here, the key tool is Smart Spice, but there is a lot of tools around the core spice simulator. You need a waveform viewer. Very often, you have too many parasitics to be able to do a quick spice simulation, and so you do parasitics reduction. That's our Givaro product. You want, if you do more than one extraction, to be able to do some analysis and compare the things, our Viso tool suite. And then often you don't want to do just one simulation, corner analysis, for example, in standard cell characterization, but also statistical analysis, and that is done by Varman. And as I said, the models themselves, right, are done by Atmos, which I already showed you in the previous slide. If we move now to IP, and I'll spend maybe a little bit more time here because this is one of the things that we actually do in Brazil, right? We have tools that generate foundation IP in the form of standard cell library generation, Cello. Here, what you do is you input essentially a net list, right? The cell that you want, and Cello will generate the layout automatically according to the Foundry rule decks, right, for that particular library. You can optimize libraries for timing, you can optimize them for power, you can optimize them for size. Libraries have to be characterized. That is traditionally done as in what is known as corner analysis. 3 corners PVT gives you 27 simulations, but more advanced nodes are also characterized statistically, right? And this is where Varman comes in, right? And so Viola works together with our Smart Spice and Varman products to characterize the standard cells. And then we have a library analysis tool, the Liberty Analyzer, right, which looks at trends, outliers, ports, reports, and make sure that everything is in order. Our standard cell IP comes in forms of standard cells, so you can purchase from Silvaco either the tools to generate the standard cells or libraries themselves. We have delivered over 50 libraries with many foundries, right, all the way down to 12 nanometer nodes. In terms of library creation, if you use Cello, you can create or migrate standard cell libraries. Creation is if you input a schematic, which is just the circuit, right? And you have, of course, to enter also the rules, right? The layout rules, the PDK of a particular process, and then the tool will automatically generate the layout. If you already have a library and you want to port this library, right, that form of layout to a new technology, we can take as input the layout instead of the schematic and move this to a new technology. And then Viola does a standard cell characterization in the traditional form, essentially running a lot of simulations. It's hard to read that, right? But what is in there in this box, right, is essentially the SPICE simulator that generates all the curves, delays, etc., that you want when you're doing standard cell characterization. An example of this, if you look into more detail, right, Cello supports mature nodes. As mature nodes, we understand nodes that are 20 nanometers and above, and those are typically not FinFETs, but planar CMOS. In terms of more advanced technology, right, we support FinFETs all the way down to 5 nanometer, right, and we can do this as new library creation. We can do down to 10 nanometers and library migration. Sometimes that's more difficult, right? 5 nanometers and 7 nanometers in our roadmap. We can do library migration for optimization, where you have a library and you optimize it on the same technology, maybe changing a few rules again for these different things, right? And then if you get a PDK update, if something changes in the process, a design rule changes, for example, you need to adapt the library, right? And we can do that too. And another thing that we do in Brazil is SPICE simulation. And so I just want to highlight a few of the things that we think is unique to our SPICE. As you all know, SPICE is the oldest tool, comes from the 80s, from Berkeley, right? The circuit simulation was the first design automation tool done. And one of our unique solutions for thin film transistors is a 4-terminal compact model. Typically, transistors are 3 devices with 3 terminals. If you also consider the bulk, the substrate, you have a 4-terminal model, which is a little bit more complex, but more accurate, right? For TFTs, we support that, and that helps particularly our customers in the display segment, which, as I told you, is our largest segment, our largest market segment. And then we have different modeling features, such as hysteresis and stress effects, that are also targeted particularly, right, to our display markets. Here you see the equivalent 4-terminal TFT compact model. If you look at a TFT transistor, right, it's not a particularly complex device. It's not very complex, for example, compared to FinFETs, right? This is sort of a planar device, but since it's a thin film transistor, it's a little different from traditional planar transistors. And the equivalent electrical model, which is what the extract, right, is, you can see that on the right-hand side. And this is a model that our competition in general does not support, and we are very proud of this kind of technology. In terms of IP proper, we sell IP blocks. These are pre-designed circuits in different domains. We do automotive, IoT, and machine learning. In automotive in particular, we license IP from NXP. NXP is one of the most important semiconductor providers to the automotive industry. They have IP things like FlexCAN buses, etc., FlexRay and CAN buses, which you use in automotive. And the things take a very, very long time in the automotive to be qualified. Automotive has a relatively long product cycle, and you have to support the things, right, for tens of years at a time. And so it's very important to work here with a large company that has the tradition and has technology that is deployed. And so our automotive solutions are essentially sourced from NXP. We support them and sell them. But we also do other business, right? Like we play in the ARM ecosystem. Here we have the AMBA buses, which is the interconnect that is used by ARM processors. We sell processors proper, right? For example, IBM's Power PCs, embedded Power PCs, right? We sell that. We go all the way down to PHYs, which are the electrical circuits that interface IOs. And I already mentioned, we also have foundation IP, memory, IO, etc. All of this is supported by an IP management tool, which allows you to what we call fingerprinting, right? Fingerprint your IP. It watermarks it, so to say, fingerprints it, so that you can figure out later where it's being used, etc. This may not seem as a big problem, but if you have thousands and thousands of IPs, which is used in many, many products, right, it becomes very important to be able to actually trace your IP and know exactly where it's being used. To end, perhaps a summary, right? What are the highlights of Silvacos? Why do our customers choose us? There's, of course, much larger EDA companies, as you all know, right? Yet Silvaco, which is one of the oldest ones, has managed to survive and thrive over 30 years by playing in specific market segments. So we have best-in-class solutions for display technology, and we also have leading TCAD solutions for power devices in general and for newer technologies such as silicon carbide and gallium nitride. We have a complete design flow, which is used with more mature technologies, in particular also in the market segments in which we play, power and display, memory, right? And to some extent also analog mixed signal. We have IP solutions, which we source also from third parties, which are proven in the marketplace for consumers and in particular for automotive. Our foundation IP, embedded memories and IOs are state-of-the-art. They can be generated automatically. 90% plus of the cells that we actually market of standard cells, right, are generated in memories. This has been customary for quite a bit of time. Because memories come in all kinds of sizes, bit width, etc. They're typically generated. You don't sell predefined memory blocks. You have to adapt it to the actual design. And then, as I told you, right, we have a patented fingerprinting technology so that we can administer IP better. And all of that translates into agility. We're very customer friendly. We work with the customer, and we are more likely to change our products, to augment them, to adapt them to our particular customer needs. And with that, I want to thank you. I think we have a Q&A later on, and I'll pass the baton, I think, to Bernardo, which will tell you a little bit more about what we do in Brazil. Again, thanks so much for your interest.
Wow, thank you, Dr. Raul Camposano. A lot of information. Thank you. Hi, guys. And who has question, please, you can leave your question in the chat, okay? Could be in Portuguese, could be in English, could be in Spanish, okay? Let's go. So, and our next speaker will be Mr. Bernardo Culau. He is Director of Library Characterization at Silvaco here in Brazil. And Mr. Culau, it is a pleasure to us to have you here. Please, the floor is yours.
Thank you, Protásio. Thank you, Raul, for leading the way, and all the folks at SBMicro. It's a pleasure to be here. So I have been working with EDA and microelectronics for 16 years now. I'm responsible for our library characterization product line, and as was said, I started and lead the Silvaco R&D Center in Brazil. So in this presentation, I hope to be talking a little bit more about the work done over here, some of the interesting challenges we are addressing, and about the opportunities for joining our team. But let's begin by how our presence in Brazil started. So after the Foundation IP Group joined Silvaco in 2018 as part of the Nangate acquisition, we needed to expand our R&D, and we chose to do it here in Porto Alegre. There were several reasons to do it here, but especially from the understanding that in here we have the opportunity to find talented people with universities with recognized microelectronics and computer science programs around us, which are fundamental to our EDA applications. Silvaco understands that it's people that are its most important asset, and finding good people is key for our growth. And we think in Brazil, it's a great place to do that. Today we have 10 people working from Brazil, and we keep looking for new talent. We have plans to start going back to a new office early next year with a hybrid format, looking for the best balance between working from the office and working from home. And we want to keep growing to be one of Silvaco's largest R&D centers, making a positive impact not only within the company, but for the microelectronics sector in our region as well. As I said, our team in Porto Alegre started by working with the Foundation IP tools, as Raul mentioned, cello, viola, and Liberty Analyzer. Today, the R&D for these tools have completely shifted to Brazil. The team here is responsible for their complete software development cycle, from design and specification through implementation, testing, and maintenance. We are also increasing our participation on standard cell library projects as a service, both in standard cell layout and characterization, and bringing Silvaco solutions direct to customers. We are also expanding beyond this Foundation IP tools. We already have people in Brazil working on Spice Simulator, Smart Spice that Raul already introduced. And we have openings for Smart Spice in Brazil as well that I will be talking about later on. And we are in close collaboration with other teams and groups in different locations to help take Silvaco solutions to the next level. One of these cases is close collaboration with the memory group from Dolphin that was acquired from Dolphin, as Raul mentioned, and we have been working together with them on the memory compiler solutions as well. I will now briefly introduce two of the challenging areas that the team in Brazil is working on to kind of illustrate the kind of state-of-the-art problems that the team in Brazil is handling. So the first example here are related to our layout automation tool, Cello. FinFETs have become perhaps the standard device in later generation process nodes. They bring many advantages, but also come with additional design complexity. The number of design rules have been dramatically increasing in latest process nodes. And the biggest concern, however, isn't just the number of the increasing design rules, but their interdependency as well. So if one rule has a dependency on other, that creates even more challenges to the layout engineer. So this increasing number of rules, their increasing interdependency, they are bound to have a negative impact on layout engineering productivity. There's also the difficulty of tracking the total number of design rules is likely to lead to an increased number in rule violations. And unlike rework on older planar technologies, the ability to fix these design rule violations can itself be more difficult as well. There is a clearly a huge productivity loss on FinFETs when compared to older planar technologies. So our solution to help address the complexity of FinFET layout is to increase its automation. One of the challenging aspects of automating FinFET layouts is the transistor placement and intra-cell routing that are not independent steps, right? So placement needs to take routing into account, even when specific routing optimization criteria exists. And basically, we need to assess the layout routability even without routing it first. And to solve these problems, we are working with sophisticated search algorithms and solvers to find optimal layout results. So very interesting, challenging, one of those that are being addressed by our team here. Our second example is from our library characterization solutions. And well, it's also related to FinFETs and advanced technology nodes. It's about process variation. So in the library characterization context, we have variation as any and all deviations on the manufacturing process and operating conditions that affects the circuit electrical behavior. Variations in the process, the oxide thickness variation, Randall dopant fluctuations, and lithography-induced variation. Well, just to name a few. Right? These manufacturing problems in modern technologies, advanced nodes, they have a significant impact on the circuit time. Therefore, we need detailed representation for their impact. And that is done with variation-aware library characterization. The Liberty Variation Format, or LVF, is the current standard to model process variation, timing effects for advanced nodes, like 22 nanometer technologies and below. It is especially important for variation-sensitive corners, such as low voltage and low power corners, where variation distributions can be quite high. And it models each timing data in a library as a Gaussian distribution from its nominal delay, nominal timing information, using early and late sigmas to model non-symmetric Gaussian distributions to the early side or to the later side of the nominal timing. The main problem is that for even newer technologies, especially 10 nanometers and below, modeling timing variation as a Gaussian distribution does not yield sufficient accuracy. As we can see from the plotting here, with the cross market on the right side, when we attempt to identify the details of the distribution, perhaps modeling them as a Gaussian distribution would not yield the correct result. This representation, this new representation needed to accurately represent the tail of the distribution leads to what is called the moment-based LVF model. So while the variation was a Gaussian distribution, some assumptions could be made that were enabling us to significantly reduce the simulation effort needed to build an LVF library. But these are no longer the case for these advanced non-Gaussian distributions. We really need Monte Carlo spice simulations to identify the shape of these distributions, and to have Monte Carlo simulations for each scenario in a standard cell library that requires a huge simulation effort, and it's really not feasible for complete libraries. So really the state-of-the-art challenge that we have here is to apply some machine learning techniques to reduce these Monte Carlo simulation efforts, to make it possible to model these distributions with a sort of a fast Monte Carlo approach. Of course, the solution needs to be robust and work for all cases, while maintaining sufficient accuracy when compared to the golden standard, which is the full Monte Carlo spice run. So now that we visited some of these challenges we're working on, I would like to switch the topic to an overview of yet another family of products that the team in Brazil is starting to collaborate on, which is the IP management tool suite, that the problems that Raul already introduced to us. We have a lot of interesting challenges relating to these solutions, with new opportunities to be part of it in Brazil as well. So the reuse of IP blocks have significantly increased over time. Not only that, but the number of different IP blocks used in a SoC is continually increasing. And for a company to keep control of all that, it's a very challenging task. Keeping control over these IPs are important for several reasons, but two of them, perhaps two most important of them, are to make the IP reuse by the design teams easy. They need to be able to find the available IPs easily and have clear information about them, and being able to verify at a company level that the IP is included in an SOC, so that make it easier to know that what verification is needed for this, and ensuring licensing compliance. Licensing compliance is really important here. It's with the increase of IP blocks usage over the years, there was also an increase in lawsuits relating to that, with people using IPs that were not supposed to, and it's probably, at least in part, due to insufficient control over these IPs. So to handle those problems, our IP management solutions include two products. The IP Vault, to centralize all information about IPs for design, support, and management teams, and the IP Audit, to discover and track IP usage within SOCs. So the IP Vault is really like a portal for product distribution and centralization, managing IPs internally as oh, I think IP Vault is like a portal, right, for IP distribution and centralization, managing IPs internally as well as from external providers or to external customers. It's not unlike other portal and distribution applications from web-based companies out there, with its command line and web interfaces. It's and all based on a real modern architecture. And IP Vault is focused, and it's what makes it different. It's focused on all elements necessary to IP catalog and distribution, include legal compliance and contract management, with all the unique things that we have in dealing with IP licensing and contracts. But to me, the really cool feature is with IP Audit and its IP tracking software, the fingerprinting, as Raul pointed out. It can search the RTL code and find out exactly what is in there. And the IP Audit is really a tool that can even enable more IP reuse, right? Because when people trust and have ways to verify that their IP will be used under the license terms, they are more likely to make more business and to allow this IP to be used. So now that we had a glance at the projects that we're working on in Brazil, let's talk about job opportunities we have here with Silvaco. So to contextualize, these are the jobs that we have in Brazil today, right? We have R&D software engineers, a job that involves researching on leading edge topics and developing new solutions and features while using modern development methodologies and tools. And as application engineer, the job is to support customers and perhaps field application engineers as well around the world, being the specialist, and also to drive R&D requirements for new solutions, and especially in the case of foundation IP, to use Silvaco tools to automate and deliver high-quality services projects for our customers. That means creating and characterizing highly optimized standard cell libraries, which is another product that we have in the in our group, as Raul mentioned. So Silvaco offers a chance for people to collaborate with a highly skilled and supportive engineering team locally in Porto Alegre, and at the same time, a globally distributed engineering team collaborating with colleagues and customers across the globe. And especially perhaps for junior engineers, a chance to learn more about design flows and industry standard practices, and get first-hand contact with state-of-the-art algorithms and programming languages, and to apply all this to tackle complex industry challenges. So these are the usual minimum requirements we put out for the open positions within the Foundation IP group. To work with these exciting advanced technologies, we have opportunities for computer science, computer engineering, and electrical engineering candidates, both on bachelor level, master's, or Ph.D. And as we see from the type of challenges that we are addressing, our engineers need to have solid programming skills, as well as an understanding of, just to some level, to understanding of circuit design and the physical and engineering problems that we're solving, right? So English is, of course, fundamental to work on this field. It's also important to note how many soft skills we have here, and how important it is to work on them as well, constantly. Good communication skills, self-driven, committed, and motivated mindset, good organization skills and professionalism, and being focused on improving and making a difference. I also want to point out at this point, we are expanding our opportunities and integration with local universities, starting to take in interns as well. So we hope to have more and more opportunities for students as well. As I mentioned, we had open positions for the IP management team with the IP Grid tool suite and the IP Vault and IP Audit products. We have the IP management framework has many exciting challenges and opportunities. The current technology stack is built on industry standard leading edge building blocks used in distributed systems. The candidate would also be involved in developing application-specific search features utilizing advanced machine learning techniques. And to become the standard in IP management solutions, Silvaco is looking for engineers interested and or experienced in the following areas: understanding of full stack development, backend development experience with one or more languages like Golang, C++, Java, Python, web front-end technologies, database management systems, API design and implementation. And we also have open positions with circuit simulation with SmartSpice. We are now looking for application engineers for our circuit simulation team. We have openings for both a junior or entry level or senior application engineers. And the job involves supporting customers and field application engineers as a specialist, working closely with R&D for specification or major R&D projects, and provide overall support for the related products. Right? We have openings for entry-level experienced engineers, preferably with experience in some level of experience, right, in SPICE simulation of analog and RF designs, experience with SPICE control languages, and as well as scripting in general. So to wrap it up, semiconductor challenges span from the levels of atoms, devices, and end systems. Silvaco is committed to address them by developing automated solutions for state-of-the-art industry challenges with competitive and affordable software, design IP, and world-class support services for engineers and researchers across the globe. Silvaco wants to continue being the technology behind our customer success. With our local R&D center, we hope to be a positive influence and help boost the high-tech sector in Brazil by training local talent and providing opportunities for it to stay in the region. And we have exciting engineering opportunities to be part of all this together with a global and growing team here in Porto Alegre. And well, for more details on our openings, please check our LinkedIn page. We have all the details on the open opportunities in there. That concludes my talk. Thank you very much for everybody for your time.
Wow. Thank you very much, Mr. Bernardo Culau, okay, for your presentation. And we are supposed to spend just one hour in our all meeting, okay? We go directly to the question and answer session, okay? So we have some questions here, but I have a personal question, okay? Let me see. Dr. Raul Camposano, it is my personal question, okay? I know Silvaco tools, but I know that Silvaco is very strong in TCAD technology, TCAD software, okay? But right now we know that Silvaco is going to TCAD to IP solution. So what distinguishes Silvaco from its competitors?
You mean what is the differentiation that Silvaco has to the competitors? Yeah, I think that's a very good question, right? Because being a smaller company, right, competing with giants that are multi-billion-dollar companies like Cadence and Synopsys, there needs to be something, right, that keeps attracting our customers to us. And so I think that to name a few, I think first picking the right segment. So in TCAD in particular, right, I said we are strong in three particular segments, which are display, power, and memory, which and that is not, right, the largest segment, which would be CMOS and FinFETs, right, and really advanced process nodes. And so these are slightly smaller market segments, but they have their own challenges, different materials. In displays, things like lasers need to be simulated, quantum dots, and so on and so forth. In power, silicon carbide and gallium nitride are coming up, right? Those are different materials, different combinations. So we have segments that matter to us, and where we have the leadership because we focus on those segments. They're smaller and do not attract perhaps so much interest, right, of people that are looking for larger markets. So that is one, picking your market segments very carefully. The second one is that we really work very close with the customer. And because we're small and we're nimble, we are capable of introducing particular solutions, right, that our customers need. And I mentioned two of them. One is this 4-terminal TFT model, which the competition does not have, right? The other one is modeling stress effects in TFTs, right, and hysteresis effects in TFTs, which again is a specialized market, right? It's technically very challenging, right? And once you have it, you have the leadership in that particular market. And so I think that those are really the two main things, right? Working with the customers and picking out the market segments very carefully.
Wow. So we have a question from our audience here. Jacob Swart asked, how many open positions are presently in Porto Alegre?
So if I may, this one row, we have open positions, but most of them are not exclusive to Brazil. Being directly included in the global of Silvaco, we have, I believe, perhaps 5 open opportunities now, but they are not exclusive to Brazil. So they are globally, like with the IP management, with Smart Spice. So they are not excluded to Brazil. They can be filled perhaps another part of the world, but yeah.
Okay, great. We have a question from Leonardo Nogueira. I think that it is to Dr. Raul. What are the main difference between student from Brazil from student to other countries? Do you find out some difference?
Yeah, maybe. I mean, I cannot comment in great detail about Brazil, right? Because I've visited many times. I myself studied in Chile, in South America initially, and then I went to Germany, right, and got a PhD. But I found that in general, education in Latin America, right, is very broad and generalistic, which is a very good thing, because once you learn basic science, once you learn basic techniques, you can easily specialize, right, later on. While in more developed countries, right, education specializes much quicker, right, and you have, in a sense, a deeper but more narrow education. And so that's as much as I can say. I think that that the other advantage of Brazil, besides the education per se, and I've met over the years many colleagues, right? You have people, of course, that did their PhD all over the world, in Stanford, in France, right, and so on and so forth. The other advantage is that Brazil is large enough, perhaps the only country in South America that's large enough, that it scales. And so if you want to open an office, not with just a few people, right, but then be able to really source from a large pool of talent, right? You can do that in Brazil, while in smaller countries that's more difficult. Perhaps you want to add something, Bernardo?
Yeah, that was very spot on as far as I could tell. When it comes to the education in Brazil, I guess it's the same case for Chile as well. It's completely possible to have education here that is included in the global community. Like we have very good centers in here, so there's not much left behind when compared to these other centers.
Oh, great. We have a question here from Jacob Swart. Any suggestions for universities to better form well-prepared students for the jobs in the field?
So the points that I raised perhaps raise this a little bit. They need to have all the tools to learn new technologies and handle state-of-the-art problems, the basics, as Raul pointed out. Having this broad perspective, and then perhaps what might be missing is some more initial guidance on what is happening now in terms of where they could start learning to be ready to join the industry.
Oh, Great.
Yeah, and if I may add, right, very quickly, we have positions all over the world for internships, and I think that is a great way of getting acquainted with how industry does things in reality, right? And so, if you're a student, right, and you want to spend a few months of your vacations, unfortunately, working in industry and figuring out, right, how things are really done, right, that's a great way of sort of getting a practical view of what is really needed and how things are done.
Okay. And a general question, I think that we have right now, due to the pandemic situation, a shortage of semiconductor, okay? Dr. Camposano, what are your vision about this shortage of semiconductor right now?
Actually, it just turned around. If you follow if you read the news, right, we had a shortage until fairly recently, and now people say we have a glut. As a matter of fact, right, I was reading the New York Times, the Wall Street Journal, right, only yesterday, and there is a large evidence, right, that now there's overproduction of semiconductors. The first ones to report that were memory companies, right? Micron and Toshiba, they all lowered their expectations, and they are considered sort of a bellwether. So I think that that this is no different. I mean, it's different in that I think the cycle has been bigger, right? Because there was such a large consumption of electronics during the pandemic, because people stayed at home and needed electric things like computers and phones to communicate. The overinvestment, which is what leads to the glut, right, was perhaps more extreme. I think that the situation this time is going to be unique, not just because of the pandemic, but also because of the sort of the trade war between China and the US, right, which further complicates the things, right? But I don't think there's any sign right now of any long-lasting shortness of semiconductors. If anything, we're moving into a glut.
Yeah. Yes, I tried to buy some Raspberry Pi 4. There is no more in the market. No more in the market. Okay. So, and let's see if we have some question here. And the Mr. Bernardo Culau, could you tell us how did you join the Silvaco?
Right. So I used to work with Nangate, company that was acquired by Silvaco, and I have been working with them for many years prior to Silvaco. It all started from really the industry and university partnership that Nangate had with URGS back then. So there is another example of how important it is to get the industry, the companies, and universities close together.
Okay. So, well, I think that there is no more question for our audience, and I'm pretty sure that because your presentation of you two was very complete, and I'd like to thank you very much for both presentation. Okay, and let's go to the end of this SBMicroHUB with the final remark of please, Mr. Bernardo Culau, your final remark to our audience.
Right. So as I mentioned at the end of my presentation, we have several openings. We have several opportunities with Silvaco in Brazil. I recommend everyone that is interested or that would know somebody that would be interested to point it out to Silvaco, to our website, to our LinkedIn page, and find out more, get in contact with us, find out more of how you can fit this industry if you're interested in that. Thank you.
Thank you. And Dr. Raul Camposano, your final remark to our audience.
Yeah, thank you very much for the opportunity, right? And we used it to sort of show a few opportunities that there are at Silvaco. I think that it's a very nice synergistic things to be able to work with academia, with industry in Brazil, right? And so if you're interested in this field, please contact us, and Bernardo is our person in Brazil. Thank you.
Oh, thank you, too. Well, let's go to the end of this first SBMicro of this season, okay? And I hope that you all follow our social media of SBMicro that will have in time to time new SBMicroHUB. Okay, so thank you everybody, and thank you Dr. Raul Camposano, thank you Bernardo Culau, and thank you Professor Azambuja to control all these things here. Bye bye and see you.
Bye.